The movie Big Hero 6 follows the story of 6 young science geniuses as they use their technology and inventions to fight a supervillain. One of the 6 scientists is Honey Lemon, a chemistry whiz. In the movie, she uses several chemicals and chemical reactions to fight the bad guys. For this project, I did some deep digging to find out if her inventions are backed up by actual chemistry. One of the inventions she uses is a multicolor expanding foam that traps the opponent and renders him immobile. This clip shows her practicing on the butler. This reaction looks very similar to the elephant's toothpaste experiment. In this experiment, hydrogen peroxide and potassium iodide are added together to create foam. The potassium iodide acts as a catalyst to release an oxygen from H2O2 and form water and oxygen gas. The oxygen gas is released and creates a mild foaming effect. When soap is added, the oxygen bubbles are trapped inside the soap to create a large amount of bubbly foam. If food coloring is added, the foam turns bright colors. I watched several videos of the elephant toothpaste experiment to figure out how much liquid hydrogen peroxide would be needed to create the amount of foam shown in the movie. I estimated 50 milliliters of 35% H2O2 solution would be needed. 35% H2O2 means the mixture is 35% H2O2 by volume, so in 100 milliliters, 35 milliliters of that would be H2O2. Using the density of H2O2 in the molar mass, I calculated how many moles are in 1 liter of solution and figured out the molarity of the solution. So the 35% H2O2 is 15 molar. Using more dimensional analysis, I calculated 0.75 moles of H2O2 and 50 milliliters of the solution. In this reaction, Ki, so potassium iodide, is a catalyst and does not change the composition. Ki is a safe substance that is used as a medicine after radiation exposure in humans, so it would not be overly dangerous to have this as a product if it's at a low concentration. Next, I calculated the heat of reaction for this reaction. The heat of formation of H2O2 is 191.2 kilojoules per mole, and the heat of formation of water is negative 241 kilojoules per mole. The heat of formation of potassium iodide is negligible because it's a catalyst, and the heat of formation of oxygen is 0. So the total heat of the reaction is negative 866 kilojoules per mole. So this is an exothermic reaction that produces a lot of heat. The foam product would be too hot to safely trap a person in, as it would give them major skin burns. The other issue is that dish soap-based foam would not trap a person. Honey Lemon would have to use a stickier glue-like substance. Another chemistry trick she uses is pouring an unknown liquid onto the floor of a warehouse to instantly form a sheet of ice. The movie is set in a temperate location, so it's unlikely that the floor was cold enough to freeze water. It is shown to be slippery to the other characters. Estimating the ambient temperature to be no lower than 50 to 60 degrees Fahrenheit, this includes most chemicals. One chemical it could be is glycerin, which has a freezing point of 64 degrees Fahrenheit. Glycerin is the main component of soap, which holds up as creating a slippery layer of substance on the floor. Another point in the movie, Honey Lemon uses a large flame to create a giant puff of blue smoke. Internet fans have all agreed that this is probably a reaction of potassium nitrate and sucrose, a known formula for a propellant. In this reaction, potassium nitrate and sucrose are added to form potassium carbonate, carbon dioxide, water, and nitrogen gas. I calculated the heat of this reaction to see if using fire as a reactant is accurate to the science of it. The reaction is actually an exothermic, so the fire would not have been needed to create the reaction. Furthermore, the heat of the reaction is so high at negative 20,237.4 kilojoules per mole that it would have been way too hot to be in the same room as with no protection. Overall, the chemistry and other science in the movie holds up well for a Disney animated kids movie. I really like this movie and the character Honey Lemon in particular because she's a really good representation of women in STEM. She is girly and smart, breaking the standard archetype of science women being all tomboys. She shows young women that being feminine and being smart are not mutually exclusive. Good job, Disney!